The objective of this video is to discuss adding and subtracting of polynomials. Okay, adding and subtracting polynomials really comes down to combining like terms. Here's an example of a binomial being added to a binomial. Now, we could add these just as they are here. If we recognize the fact that the adding here is going to mean that these parentheses mean absolutely nothing here, that we could rewrite this as just plain 5x squared plus 3x to the fourth plus 6x squared plus 9x to the fourth. Now, when we write it like that, and we realize that the addition property, addition is commutative, we can change the order here. When we change the order, we end up getting 5x squared plus 6x squared, bringing those two x squareds together, and bringing the x to the fourth together, 3x to the fourth plus 9x to the fourth. Now we can combine these like terms here. These are both x squared, these are both x to the fourth. We combine them by adding their coefficients. So this would now become 11x squared plus the 3 and the 9 add together to give me 12x to the fourth. And that would be my final answer. However, I did not put these in proper standard form here. Standard form would have the larger exponent first. So my final answer really should be written as 12x to the fourth plus 11x squared. Would I mark you wrong if you had this as the other part as an answer? No. But this is really the right answer here, with this being a squared here, 12x to the fourth plus 11x squared. Now, I like the vertical method, but some people prefer to have a horizontal method of combining the like terms. That's where they take these two binomials and they write one on top of the other. Now, if you're going to do that, I would make sure that you write them in standard form, which means the higher exponent is first and the lower exponent is second. You've got to rewrite them anyway, might as well do it right. So the first thing I would do is rewrite this as 3x to the fourth plus 5x squared. And underneath, I would add 9x to the fourth. I have to make sure that I line up the right exponents with the ones that are the same, the like exponents, those like terms, and then a plus 6x squared over here. Add them this way, I get 12x to the fourth plus 11x squared. Remember, I'm not adding those exponents. They get carried along like luggage. 3 apples plus 9 apples gives me 12 apples. 5 oranges plus 6 oranges gives me 11 oranges. No fruit salad and math. I can't combine these apples and oranges to make one term from there. Okay, let's talk about subtracting polynomials. When you've got subtracting, you can't just ignore these parentheses. Unfortunately, you can't. This set, you probably could ignore these, because as far as whether you're subtracting this from this term or this from that term, it doesn't matter what you're subtracting from. You are subtracting from this sum as a whole. So you could technically get rid of those parentheses. But you can't get rid of these because it's not plus 2x and plus that. It's minus these things. What I like to do is I like to change this into adding a negative. Subtracting is the same as adding the negative. And when I do that, I make this a -1. So what I'm really doing is I'm going to have a -1 times the stuff in there. Okay, then from there, I use a distributive property to distribute that negative throughout this binomial here. So it's going to be -1 times the 2x to the fifth, -1 times the -3x to the third. So this would become, well, the 4x to the fifth, just that would stay there. 6x to the third would stay there. And then this would become negative 2x to the fifth. But a negative 1 times the negative 3 is going to make this a positive 3x. So I'm going to have a plus 3x cubed there. Now I rearrange to make the combined terms next to each other there. So I'm going to rewrite this with the highest exponents first. So I had a 4x to the fifth. I'm going to bring this negative 2x to the fifth, including the sign with it. When I move these things, I have to bring the sign with it. Bring it over here. I got a negative 2x to the fifth power. And then the thirds, I'd have a plus 6x to the third power and a plus 3x to the third power. So from there, let's see if I can get those a little bit better here. Let's x and x. All right, then I would combine my like terms. Negative 2 and positive 4 are going to give me 2x to the fifth. These two are combined to give me 9x cubed. These two combined give me that. And they're both positive, so I end up with 2x to the fifth plus 9x cubed as my answer. All right, now we come to the you do part of the video. I'm going to ask you to pause the video and try these two on a piece of paper. Come on, try it on the paper first. All right, welcome back. All right, what we're going to do here is we're going to rewrite this. We're going to the first one here. We can ignore those parentheses. We can ignore them because of the addition here. And we're just going to rewrite this whole thing in standard form, putting the highest exponents first here. So I'll start with a negative 2x to the fourth, and then I would have a negative 3x to the fourth. And then I would have a positive 7x squared and a positive 2x squared. Then I would combine the like terms. These like terms combined would give me a negative 5x to the fourth. And these two here, 7 and 2, would give me a positive 9x squared. So that would be my final answer there in the pink. Sorry about the crossover on that. All right, so let's see. Let's look at the next one here. Let's do this one in blue. Here we go. Now we're going to distribute the negative to those two terms. So this is going to become 4x cubed minus 5x to the fifth. Negative times a negative is a positive 2x cubed. Negative times a negative is a positive 3x to the fifth. Then we rearrange to put the like terms next to each other. So we're going to have a negative, we have a negative 5x to the fifth plus 3x to the fifth plus 4x to the third plus 2x to the third. Then we combine the like terms here and the like terms here to get our final answer of negative 2x to the fifth plus 6x to the third. And that would be my final answer. All right, to sum it all up, adding and subtracting is all about combining like terms. And when you're adding, you can ignore parentheses when adding, so these things can just disappear when you're adding. When you're subtracting, you need to distribute that negative 1 to both terms in the second one here, and then combine like terms. Thank you for watching.